Hello, wonderful people. This is Mr. Manson, and this is some help with assignment 3. For this particular assignment, we're going to be looking at exponential growth and decay. Our goal is to find the multiplier and determine whether it is a growth or a decay, and then we're going to find values in exponential models. So remember, we always start with 100% of what we are given. We add it if it is a growth. We subtract if it is a decay. So for number 1, this one has 7% growth. So we would start with 100% of what we have, and we add 7% growth to that. That gives us a total of 107%. Now remember, there's a decimal here, so to remove the percent symbol, you simply move the decimal 2 places to the left. So our multiplier is 1.07 for that particular value. So that's how you would do that. So that's what you're going to do down here for numbers 1 through 8. All these growths you would simply add to that. So for example, like number 7, start with 100%, add 6.5%. So that's like $100 plus $6.50. That will give us $106.50 percent. If I move that decimal over 2 places to the left to remove the percent symbol, we get 1.065. That would be the multiplier for that particular growth. For decay, this is for 9 through 16, you simply subtract. So for number 9, we would say 100%, and we would subtract 7% for the decay. That will give us $100, take away $7 is $93, or 93%. Remember the invisible decimal point, and that moves over 2 places to the left. So remember, anytime you're a growth, your multiplier will be just above $1. If you are a decay, you're just under $1 or below 1. So that's what you're going to do 9 through 16 here for the decay. Let's take a look at number 16. This one here, 100%. Now this one, you have a decimal within the percent, so be careful. 0.25%. This is like saying if you had $100 and I took away just 25 cents, you would be left with $99.75. So then you move that decimal over 2 places to the left, and that'll give you 0.9975, just like that. So it's a really, really small decay. For the next set, 17 to 24, you just simply have to tell me if it's going to be a growth or a decay. So first on number 17, we identify the multiplier. The multiplier is the base. It is the larger number that holds up x as the exponent, the variable. So here the multiplier is 5. Since my multiplier is greater than 1, that indicates that that is a growth. So you write growth for there. So remember, anytime you're a growth, you're always going to be bigger than 1 or greater than 1. If you're a decay, you're going to be less than 1. So let's say number 19. It says 0.25 to the x. That's like saying all of this number is being raised to the x. So as x gets larger, what's happening to 0.25 as it gets there? Well, since 0.25 is less than 1, we would say that that's a decay. So you're just going to simply go through these and label whether it's a decay or a growth. If you look at number 24, here we have 6 times 1/2 to the x. We only look at the multiplier, so we don't care about the 6. So right here, 1/2 to the x, since 1/2 is less than 1, we would say that's the decay because 1/2 is the multiplier. And then the last part of this assignment. These are the exponential models. So let's start with number 25. It says here, movie tickets are now average $9.25 a ticket, but are increasing 15% per year. How much will they cost 5 years from now? So we need to find whether it is a growth or a decay. So for this particular one, since the movie ticket prices are increasing, this one over here is going to be a growth. So we'll circle that. For part B, it says, what is your multiplier? Well, The multiplier is the number, it's how it's growing, so that's 15%. So I take 100%. Let me scoot that over this way so you can see it. And then we add 15%, and that gives us a grand total of 115%. So to get our multiplier, we move the 2 decimal places over, and we get 1.15 for that number. And then we want to set up the equation and solve it. Okay, so to set it up, we simply say what our starting amount is. So in this one, we're talking about movie ticket prices. So it started off to be $9.25. So let's write that, $9.25. And then times, that's going to be our multiplier, which we got up here to be this number, 1.15. And we raise it to the time. That's how long we're trying to find out something is growing or decreasing to. So 5 years from now, we raise it to the 5. And you'd simply plug that into the calculator to get that value, and you would get the answer to that one. Let's jump down to number 28. On number 28, John's new car is worth $25,000 and is depreciating 8% per year. Depreciate means you're losing money, so you're going to say $25,000 is the starting amount. The multiplier, since you're losing 8%, that's 100% minus 8%. That will give you 92%. So moving that decimal over 2 places, it's 0.92. And then you raise that to how long, which would be to the 5 years. Unfortunately, I don't have a calculator in hand at this moment, but you simply plug those numbers in the machine and get the value for that. The rest of the ones are pretty self-explanatory. You can either print this out, work on this, or what a lot of students have been doing is copying this on another sheet of paper and taking a picture of that. And I just ask you to please post the assignments on the Google Classroom. If you cannot get it on the Google Classroom, please send it to me by way of email. Thank you very much and good luck. Take care.